have four distinguished speakers talk about the subject. First, we are going to have Bjorn Sauter from Festo, who's going to give also a very, how can I say, also human-oriented aspect of advanced digital manufacturing. Afterwards, we'll have Ioanna Zeriotti, who's going to talk more about technology and particularly lasers. Then we'll have Ricardo Dueno, who's going to talk about processes and machines, etc., related also to advanced digital manufacturing. And at the end, we will have Rika Virkunen from VTP, who is going to talk globally about the way for future, some examples, some important issues as far as I can talk loud, that's okay. I'm a loud person. So anyway, this is the program. The way it's going to work is we're going to have the presentation. If you have some burning question, then we can take one or two questions after the presentation. And at the end of the session, we'll have some sort of round table where everybody can pitch in the discussion. So Bjorn, the floor is yours. Unless you would like to sit there and leave the microphone in place.
No, I just would prefer here to stand, and I have just to go there to click the slide. So thank you very much, George, for your kind introduction. Mesdames et Messieurs, ladies and gentlemen, it's a pleasure for me to be here together with you in Grenoble and to open this session on advanced digital manufacturing with my presentation entitled Experience the Future, Digital Solutions for a Future-Oriented, Competitive and Sustainable Industry. And with my opening presentation, I want to share with you two key messages. Message number one is digital advanced manufacturing is a key enabler for realizing this twin transition, this transformation, digital and green transformation of our industry towards such green factories. And key message number two is human factors matters. So human experience is key when it comes to realizing new technologies, advanced digital manufacturing technologies. Yeah, human experience is a very important thing when it comes to implementing technologies. The best technology is of no use if the people are not interested or are not capable to implement this technology. So it is important that the people make their own experience with technology, play with technology, and are not afraid of new technologies and new solutions. And from my company, it is very important that even the youngest children make their own experience and learn how to play with technology and to be inspired. And it's not only important for children, but also, I would say, for policymakers. It is important to make own experience with advanced manufacturing technologies. This picture, if you see it from the back, you are also invited to come closer if you cannot see it from the back here. Here you see this picture from the presentation of the world's first pneumatic cobot at the Hanover Fair 4 weeks ago. So we presented this cobot to the German Chancellor Olaf Scholz and Portuguese Prime Minister Antonio Costas. So human experience is important for successfully implementing new technologies. And I would say this is also important for all the people who are involved in developing new programs, research and innovation programs. So also people from European Commission are invited to make this experience. And policymakers, this brings me also to the first key message. Advanced digital technologies, advanced digital manufacturing technologies, what we also call from Germany, in Germany, Industry 4.0, is a key enabler and I would say also the right framework to realize Europe's 2030 sustainability goals. as said, for example, in the new social or Green Deal contracts, and you know all the Fit for 55 activities. So here on the left-hand side with the 2030 vision for Industry 4.0, on the left-hand side you see that sustainability is one out of 3 core pillars, and it comprises decent work and education, social participation, and also climate change mitigation and circular economy. So we are not only talking about technology. And on the right-hand side you see also some recent publications dealing with sustainability or resilience in the context of Industry 4.0, or also with good education and good work. So advanced digital manufacturing is a key enabler. And in one of these publications, we have identified 3 digital transformation paths to sustainable production. The first path is reduce consumption and increase impact towards resource efficient and carbon neutral digitalized manufacturing. The second path is from mass production to transparent service offerings, how our changed value proposition influences digital business models. And the third path is sharing and networking. Sustainable digital business means cooperating and operating in circular economic systems. And in the next minutes, I would like to explain these 3 transformation paths a little bit more and also give you some illustrative examples from already existing solutions from industry. So let's start with the first path. Reduce consumption and increase impact. Maybe you can read the figures here on the left-hand side. More than 40% of global electricity consumption and almost 80% of global coal consumption can be attributed to industry. So there's a clear call, a clear need for action. But we see that there's also a great potential for saving energy, especially for saving energy consumption with the help of advanced digital manufacturing solutions. As you can see here on the right-hand side, we have got more and more data available in our factories, in our machines, and we have to use this data in order to monitor material flows and production processes to be able to reduce the energy and resource consumption. And it's not only about increasing computer capacity and to produce more and more data, it is also about using the existing data more intelligently by using, for example, artificial intelligence technologies and others, which help us to increase the resource and energy efficiency. And as I've mentioned already, it's not only technology what is important, it's also about organizational and financial topics. I am convinced that CO2 neutral will become the new normal also in industry. And I believe that also sustainability indicators will become an integral part of accounting. So financial aspects are also an important issue to reduce consumption and to increase impact. And to show you 2 examples from industry, I brought you one example here for industrial data analytics. You maybe remember I have said human experience is really important, and this is the reason why we called this solution also Festo Automation Experience. So we provide to our customers an easy-to-use digital solution or tool which they can use on premises or on edge or in the cloud, and where we use the data coming from the machines and analyze the data in real time using artificial intelligence, but also incorporating human experience, the knowledge from the operators, for example, on the shop floor. And by doing this, we are able to offer predictive energy and also predictive maintenance and predictive quality solutions and services. And this helps and helped already in the past to dramatically reduce energy consumption at our clients' factories. So this is just one example how data analytics could help to reduce energy consumption. This is another example, an example for intelligent components with software-based functions. So this is a digital pneumatic valve terminal. So what we did is we replaced several hardware functions by software functions. So we are using less material and you are using more software. So this is a contribution to resource efficiency. And with this software or motion apps, how we call it, it is much more easier to adapt this component to various applications, to various application scenarios. So we do not have to take this component out of a machine when it is used for another purpose. We just can reprogram it and use it again. So it really helps us to be more flexible, and with these energy efficiency apps, how we call it, we also are able to minimize the energy consumption. So this is just one example to show that software will become more important in future manufacturing, and that it helps also to reduce the energy consumption. So let's go to the second transformation path. It's called from mass production to transparent service offerings. So the figures here are from Germany. More than 50% of industrial companies are developing new products or services, or are planning to do so. So we have got a transformation in German industry, and 45% of them are already implementing pay-per-use or production as a service models, so new business models. So this illustrates how a changing value proposition is really influencing digital business models. So as I've mentioned, we have got this data, and these data help us to develop a kind of digital representation, a digital twin, or as it's called here, a sustainable twin here, and which helps us to develop some kind of material pass, or maybe you have heard about this digital product passport, which allows to track and trace a specific component or product along the whole life cycle, and which helps in the end to close loops in a circular economy, which helps us to implement remanufacturing approaches and also to extend the life cycles of our machines, for example. And it helps us really also in the context of reverse logistics and to reuse also these very valuable materials, for example. Just one example I want to share with you, one example for digital twin-based services along the life cycle. At Festo, we implemented online interface for our customers. We call it online experience for the whole digital customer journey. So it's a contact point for the first contact for our customers, but it supports our customers also when it comes to selecting the right product and to do some digital engineering. So we provide our customers with CAD, so CAD data or behavior models, so that they are able to digitally engineer a machine, for example, or even to virtual commission the machine before it's produced or before it is established in a factory. And when then the machine is running, we also provide additional services. We are also currently working on so-called digital financial twins for new as-a-service business models. When everything is here centered around AAS, it stands for Asset Administration Shell, which is the digital twin for Industry 4.0. So in future, we will see more and more services, so servitization. And this leads me also to the third path, sharing and networking. We have over 7 billion tons of natural raw materials which will be missing without smart circular economy. But on the other hand, we already have very smart machines today. Here the statistics for Germany say every fourth machine is already smart today. So we could use these machines and share the machines and cooperate in not only in linear value chains, but in complex value networks and circular economy systems, where, for example, companies in future can offer free production capacities on a marketplace, for example. So this is manufacturing as a service. And this is one aspect which, again, helps us to increase resource and energy efficiency. Maybe it's clearer when we see here some of these use cases. When we talk about sharing and cooperating, everything is based on the data, on the existing data, and it's important that the data is shared beyond the factory boundaries. So it's multilateral collaboration and data sharing in digital ecosystems or data spaces. Maybe you have heard about this term, data spaces. So there are several use cases which we could imagine. So, for example, supply chain traceability, so that a product is can be tracked and traced along the whole supply chain, from tier 1 to tier 2 and so on, OEMs, end user and so on. Manufacturing as a service, collaborative condition monitoring is a use case. So we could imagine a lot of use cases in the field of shared and modular production, smart supply chains and logistics. It also has a lot of to do with resilience of production systems. So on and so forth. So this is, I think, a field, a topic which we are still at the beginning of this development. And when we talk about multilateral data sharing and working in data spaces, it's clear that we also need the people who are able to work in this context. And this is the reason why we also developed and launched an online platform. We call it Learning Experience, where we provide our customers small learning nuggets for micro-learning on the job, so that in our customer, the employees can advance their abilities, capabilities, as they need. So I have talked about 3 development paths. So it was reduce energy consumption, increase impact. It was about new service offerings, and it was about sharing and cooperating. And what comes next? I think everything what I've said and presented to you is also can be closely connected to new developments in the field of bio-inspired production systems. I do not want to go into detail, but this is something, decentralized technical intelligence, what we will also present in the next European Manufacturing Conference in Brussels, end of September. And to conclude, and to come back to my key messages, I've mentioned that digital advanced manufacturing solutions really are important enablers for this digital, for this twin transition, and human experience matters. So you are invited all to make your own experience, for example, by visiting a Festo Experience Center we are currently launching across Europe, but also you can visit the excellent institutes which are represented also by Joanna, Rika, and Ricardo in the next presentations. I thank you very much for your attention.
Thank you. Are any immediate questions you may have? If not, then we will move to the next presentation by Joanna. Joanna, please.
Do you want to?
Now we'll move with the technology.
Okay.
Thank
you very much. Thank you very much, and I'm very glad to be here and to present our laser-based technology. So I'm going to present you, and thank you for inviting me and the organization for giving me the opportunity to present laser printing as a digital additive manufacturing solution for electronics and processing and packaging. So this is, I mean, it is hard to have a classification of what is about additive manufacturing. This is the additive manufacturing families according to the American Society for Testing and Materials. It includes families and categories of processing. I mean, that trend has been changed a lot, the definition of what is additive manufacturing. However, this is a good representative, categorization of the additive manufacturing processes. So what I'm focusing is under the families of powder bed fusion and also under the materials jetting, where we consider as a digital additive manufacturing process. So below these two categories of material jetting and powder bed fusion, we have, for instance, for the case of material jetting, we have drop-on-demand inkjet printing, aerosol, and laser printing that I'm going to present you. And under the powder bed fusion, we can have direct metal laser sintering, multi-jet fusion, electron beam melting, and selective laser sintering that I'm going to also to present you as a combination of the laser printing. So what is about this technology that we present is about lasers that together with the additive that enables an additive manufacturing a key enable tool for the industry. So I mean, Photonics has invested a lot of also on the roadmap on the additive manufacturing enabling using advanced lasers and also processing. So there are many expectations from the Photonics Society in combination of the technology of the lasers and the additive manufacturing processes. So, and I'm coming also to the potential and the market that is expected. So this is based on the Photonics 21 analysis. Market analysis, the expected market for the photonics and laser components in combination with the additive manufacturing is expected to increase and to reach 1 trillion up to in 6 years from now. So there are a lot of expectations on where the laser components and industry can be used on the additive manufacturing processes. So, and what about the processes? What we're working is with a group of other people and industry as well in Europe, is using the laser-induced forward transfer for the fabrication of metallic micropatterns as components in flexible electronics. And I'm going to schematically present you the process. This is the video outlines what is the process about. We have a donor, a sacrificial layer, and a carrier donor where the laser hits from the backside. There is an ink which is spread on the backside of the donor material, and then the laser hits the backside of the transparent material, produces a bubble, a pressure wave, and then a jet which is injected on the receiver. And in that way, we have a kind of writing in a digital and printing in a digital approach. But of course, we need metallic inks or any other inks that are not enough to be printed. They need to be sintered, and this process is combined with the laser sintering in a way that, just after the printing, we can have the sintering of the conductive lines or of the pattern that we have in another electronic circuit. So this is an example from the laboratory. Actually, this is from my lab, where we do sintering. So the challenge of this process is where is the uniqueness of the process, is that can be combined with existing flexible electronics additive manufacturing processes, which is up to meters per second. This is at 2 meters per second, this example here. And also can be combined with flexible substrate, which is quite challenging for the rest of the technologies. So here we see some results from my group, where we have sintered silver inks, metallic inks, and we see the necking of the nanoparticles to result the optimum resistivity for the use of this electronic circuit. So I'm going to present you 4 examples shortly we have demonstrate the advancement of the process. The first example was a project that was coordinated by Orbotech from Israel with a strong presence of industry from Europe, and where we have the task was to prove that this technology can be used for the speed as a high-speed digital printing process for two specific applications. One was the laser printing of RFID antennas that was driven by Pragmatic from Cambridge, and then other application number 2 was the printing of laser printed fingerprint sensors that was from FlexEnable from Cambridge area as well. So together with companies like PV Nanocell from Israel, where they develop the inks, because this technology relies a lot on the material suppliers and on the inks that they can be prepared for tailored for the specific process, because the majority of the chemical companies are working for the most popular technologies, like for instance inkjet, where the need for the rheological characteristics is different than on this process. These are some results of high-speed printing. So we see following the optimization, of course, process, we see some nice results on the continuous line. And the challenge here is, of course, to have a good, consistent line width with a line gap, avoiding bridging for the electronics components, which is very critical, and also quite stable on the thickness across the whole electronic circuit. This is another case from the same collaboration, where this is printing of copper. Copper is even more challenging, again, primarily due to the lack of material suppliers for the copper inks tailored for the process. And this is the best results we could achieve, where we have also sintered the copper inks, and we have reduced the copper oxide, which is an issue when we sinter a copper under air conditions. And these are some nice results on RFIDs. Another example is the project that we're running now, and together with Amires, actually. I'm the coordinator of this project, and what we aim here is to advance the previous results and to demonstrate two specific applications that are more challenging. One is the OPVs, organic photovoltaic modules, and another is to further advance the organic thin film transistors for displays and wearable displays, for instance. So we have, on this project, we aim to combine the laser processing and the post-processing with roll-to-roll and photolithography for the demonstration of OPVs and the demonstration of wearable displays. Again, with strong industrial participation on this project, like for instance from Armor Group or PV Nanocell, FlexEnable, again, Picasso, who is also a French company. And here we see the latest results from this work, where we have combined the laser processing to print conductive lines as a bottom electrode for inverted photovoltaic structures. And here we see some results from the characterization with sufficient efficiency of the photovoltaic, not the optimum one, but the aim of this work is to have ITO-free, replacing the ITO with the silver grids printed by the laser technologies. And this is another case from the same work, where we have combined the printing on flexible substrates for wearable displays. And the challenge here, and what is needed for the laser technologies, is to have this digital printing, which will replace the photolithography, because photolithography is not, cannot overcome the issues of the waviness of the substrate or the pre-patterned devices. And there is a definite need for digital processing on this type of complicated structures. So here we have proven that we can get similar mobility structures in the case of lifted OTFTs compared to the standard fabrication steps. So another example of the technology to the additive manufacturing is the laser bonding and laser assembly. So we can combine this technology for the let's say large-scale bonding, wire bonding and assembly of the circuits, of the electronic circuits in any kind of substrate, but also on flexible. So this is a national project with a company from Greece, Prisma Electronics. And what we see here is the combination of printing for solder paste on PCB pads via laser printing. And in that way, we can reduce the size, we can reduce we can work on the miniaturization of the electronic circuit and reducing the diameter of the bonding and having, quite fine resolution. But again, for this process also, we need to closely work with chemists and with material suppliers company, because currently the commercially available are those that are used for other processes and resulting, higher, let's say, particle size. So, and this is the last example of the technology, and that is something that was highlighted a lot because we recently received a European Innovation Council transition as a follow-up of this FET project. So that was a project that just finished. I was the coordinator for this project as well. And the idea here was quite disruptive when we submitted, and it still remains. The concept here is that what about if we use this process to exfoliate the 2D materials from the substrate as grown? So to exfoliate either using wavelength, which is propagating through the substrate, like for instance 1.5 micron lasers through silicon, which is almost transparent at low thicknesses, and then enabling this process for digital printing on silicon electronics. And another approach was to have the laser-induced Fourier transfer, as previously mentioned, again for the transfer of the 2D materials. So that was quite disruptive as an idea. And we had, the two examples that we worked was one for the emitters together with Mellanox from Israel, and another one for touch sensors with Graphinea from Spain. And these are some, we were quite surprised to see how nicely the graphene layers were exfoliated by the laser pulse. And we see here the graphene on the left side. This is a single layer of graphene that was confirmed by the Raman spectra here and by the Raman mapping on the right side of the slide. So we could exfoliate the single layer of graphene with a single laser pulse. And this project is continued as a transition project. Will start from 1st of October this year. And the aim is to further develop the technology and enable this technology as a laser transfer process for 2D materials. That is a field which is expanded a lot. And it would be fantastic if we could optimize the technology to have a digital transfer process for the 2D materials. So with this project, we aim to work on different 2D materials like graphene, molybdenum telluride, tungsten sulfide. We aim to advance the laser digital transfer upscaling to larger wafer size, to work on the automation and advance the technology on the integrated emitters, again, in collaboration with our partners. The business case is quite ambitious, as we will, we will aim to have a spin-out from this project. So this is from the technology side. So I would like to thank you very much. These are my group and the collaborators and projects funding. So thank you very much, and I'm open for any questions, discussion.
As I said, yeah, okay, we're talking about any questions? So laser is an advantage tool for digital manufacturing, there's no doubt about it. But this was rather specialized about microelectronics. Yes. But nevertheless, the laser is advantageous. questions you may have. If not, let's move to Ricardo Bueno.
Thank you very much.
Thank you, Ivana.
Okay, good afternoon. My name is Ricardo Bueno. I'm coming from BRTA, which is an alliance of 17 RTOs in the Basque Country. 17 RTOs, where many of them are working in industrial technologies. Today I'd like to talk about intelligent manufacturing industry and addressing three different topics. I mean, the manufacturing processes, also the manufacturing equipment or machines, which are very relevant in our region, and the manufactured products, in our case mostly, or the largest amount of products are business-to-business products. So, if we go to the global context, in Europe and also in our country, I mean, manufacturing is the backbone of our economy, and Europe is one of the largest exporters of manufactured goods, of manufacturing equipment, and in this sense, we have some big challenges when we talk about digital manufacturing, as we are talking in this session. We see this very much interlinked to sustainability aspects as well. And also we see a clear evolution. I mean, we are going from mechanical manufacturers towards more integrated businesses where digital and data and so on are providing much more added value to our companies. And about digital and sustainability, I think that digital is an enabler for these sustainability aspects. So, in this sense, we need to be more sustainable. After all the events these last months, we want to have more sovereignty in our technology. And with all this, we see that there are some big trends and some big challenges around. No? So we see, in one side, for the manufacturing processes, we need to have more flexible processes and more efficient. If we go to the machines and production equipment, we see that this is also being transformed. These are more connected machines, more smarter, and this is not only for the machines, but for equipment, for components, and bringing AI to the companies, to the products, and so on. And finally, for the products themselves, we see that we have to produce in Europe high added value products, and this also will contribute to our global leadership. So this is our understanding of intelligent industry. I mean, we want to evolve from purely generating new products to related services, and we want to bring this together, technologies for sustainability that are enabled by the digital. And we want, finally, to address this sustainability in materials and processes, in design of products, and at the end to have better products with improved functionality, efficiency, user experience, and so on. So, coming to the first block, it's about processes. We are talking about manufacturing processes. And here we see three main trends, at least in our companies and in the RTOs that are providing new technologies for improved processes. In one side, more digitized and interconnected. I mean, we all see that we are able to collect much more data, parameters about our processes. We can analyze this, and at the end, this is a tool to have more efficient processes. We see also the trend towards flexible automation. It's sometimes it means this could be contradictory terms, but we see automation but flexibility, so one-of-a-kind production, and how can we do it with very much more flexible robotics and this working in an unattended way. And finally, about sustainability, okay, all this information we can collect from digital sources, from data. This allows us to implement better processes, more efficient, more circular. And in this sense, these are some of the main research lines we are addressing. So it's, of course, the production quality, digitally enabled, all real-time simulation, visualization, I mean the digital twin of production, flexible production systems, efficiency and raw material efficiency, and then new processes such as what we have heard before for advanced material, composites, surfaces, and so on. But here I would like to highlight that, okay, we are going towards a more sustainable processes, and digitalization is one of the main enablers that allow us to go towards those more sustainable processes. Another important part in our value chain is the machinery, the production equipment. In this case, we want to have a more intelligent machines, so this can be more flexible, can be closer to the operator. This can fulfill better the needs of our production industry. So in this sense, digitalization is bringing more autonomous machinery, more reconfigurable, flexible machinery, so we can adapt to changing demands, and we can self-adjust, self-calibrate, and all the digital technologies that are behind. Then also we want to reduce the environmental footprint, the energy consumption, and the cost of operation at the end, so we see this as an opportunity. I mean, the more efficient, the more sustainable machines, the more competitive we will be. And finally, machines that are more interactive, that can be closer to co-working with humans. Here we see such aspects such as cobotics or more flexible robotics, and how to address this collaboration between humans and machinery, production equipment, robotics. So these are some of the trends we see there. So about machines, we can summarize it in two main concepts. In one side, we see that our machines are much more connected than before, and we have more sensors, more connectivity, data conditioning, diagnosis, quality control, and then our machines have also are smarter, have more embedded intelligence, so this allows us to have more precise machines, more sensible, more autonomous and adjustable to the required production needs. And finally, the products themselves. And when we talk about products, and in our case it's mostly business to business products, we see that there is a very clear trend also in the intelligence of the products, or how this is evolving. In one side, we see that products are becoming smarter with more computing capability, so the products, they can take more intelligent decisions through communication, cooperation with what we have around. We have also more traceable, more sustainable. At the end, we can see how the products are evolving during their life, during the use life. We can analyze all the life cycle. We can see, we can understand how this is behaving and which is the impact of the products. And finally, we see products more embedded, more connected, embedded components, more connected products. So these products can interact between each other, and they can exchange information that will allow to be again more flexible and to adapt to to the new needs of the industry. So about product, I would say this could be the main trends in our case. We are advancing towards much more digitized products, more traceability. We see the pervasive use of digital twins, more active products. In this case, for instance, I was discussing recently with manufacturer of trains in our region. Before this, he was telling me, okay, we were just mostly a mechanical industry. We were manufacturing trains. Then electronics came, and we become mostly an electronics company more than a mechanical company. And now the main driver, it's the data, it's the software, and they are, of course, there is mechanics, there is electronics behind, but where they get most of their added value is from data, it's from software, and this is the evolution in this digitalization. So these are what we see our main trends in production processes, in production equipment, and in business to business products. And we see that, okay, we all know digital evolution, it's one of the main drivers of the evolution. But if we come to the other driver, which is sustainability, we really see that the digitalization, it's one of the main enablers for the sustainability. So this is what I wanted to comment. Thank you.
Thank you very much. Any questions? This is an overview of processes, machines, and products, and the trends that are involved. Now let's finish our session today with Rika. Rika, who's going also to give you an overview, but from a different perspective.
I don't have a watch, so maybe you can.
No, it's okay.
Stay when it's over. Okay, thank you very much. So I'm Riikka Virkkunen from VTT, the Technical Research Center of Finland, and here today trying to describe how the digital platforms and the data issues are connected to the green manufacturing and the green transition. Yes. So I think for quite many years we have been discussing about the digital platforms and the challenges of integrating the data from the shop floor to the other layers up to the business processes, and quite many efforts have been done to do the technical things, the standards, the architectures and the data sharing solutions to overcome this difficulty of collecting and managing and having a high quality data and connect that to the decision making in different levels. And this is something that has been very valuable, have advanced a lot, and we should continue on that to be able to do what the Frost and Sullivan says, to bridge the physical world, the business processes. I was talking with one of our customers about this thing and in manufacturing, a good company, and he said that he has really seen the difference in a way that a lot of data is collected now, much more than before, and the data islands that are existing there are growing. They are becoming a bigger island, so kind of an archipelago maybe, and he also sees that there are bridges between these islands, but still, many cases the data is used for quite private use. Inside the company, of course, maybe in the near supply chain or customer sharing something, but not in a broader sense. Also the machines, they are starting to talk, so to say, and produce data, but who is listening? So the ability to take the decisions back and the data back is not yet done. So, I mean, there's a lot of things that have advanced, and for manufacturing companies, this is of course complicated, or more complicated maybe than in many other sectors, because there's so much legacy systems, there's complications and dispersity or different machinery, and also you have to connect to very different players. So it is not simple, but much has
been done. Then if we are going really to think about that, how to realize the circularity and sustainability issues, but circularity in particular. So of course, all the time for the efficiency regions, we have to connect the data sort of vertically and also horizontally, and that's already a challenge, especially the horizontal thing. Even if you have your own supply chain, to horizontally really connect everything in the data-wise is not simple. But then if we go to the circularity, there's another aspect coming. You need to, like from the user's perspective, from the use, and you have to bring back the data to the manufacturing and even to the design phase. And not even that is enough, so this is a bit misleading picture, because in the real circularity you also spread it to the other sectors, so you are not only getting back to your processes, but also to the other sectors. So then, I mean, this is something where the digital platforms and data sharing solutions really are needed, and also the architectures are changing from the more central to that you have to connect different systems with different technologies somehow. And again, from the manufacturing perspective, the companies, of course, are very, many of the companies are quite used to working already in different markets and different cultures and different regulations and so on. But then if you add to that you connect your data to the different sectors, you have another dimension of complexity. On the other hand, most companies, or many companies, see that this is a very big business opportunity, because based on this shared high-value data, you can create different kind of businesses and business models, servitization, and also, of course, new businesses are coming and new companies are coming there to take advantage of this change. So I have picked a couple of examples from recent European projects and then something from the Finnish activities. I know that there's a lot of things happening within this digital platforms. I mean, platforms that are developed and can be used in manufacturing sector, and also manufacturing sector specific initiatives and research projects and hubs and whatever. So this is just a small snapshot to a cluster project that is dedicated to the digital manufacturing platforms for manufacturing, for trying to have advances in manufacturing, so more agile manufacturing value networks, zero defect manufacturing, human factors, and circularity in manufacturing. So very manufacturing focused cluster. You see the details, so it was an ICT project from 2018 and 19. So there's 6 innovation actions, and I will pick 2 examples from DigiPrime and quality, and then there's a coordination action, connected factories that I'm coordinating, the DigiPrime quality, and the other projects are coordinated by other people, so you have the contacts in the next slide, so if you're interested, so please contact them. So for the quality project, so this was one more thing about this example. So these are the examples which are now connected to the digital platform plus the green manufacturing. So I picked these examples of trying to highlight the title of today. So in the quality project, the starting point is that many of the quality systems in manufacturing are either quite reactive, so when something goes wrong or some deviations are noticed, so then we react. And on the other hand, the digital tools that are supporting the high quality and zero defect manufacturing are often for some specific process steps, not a holistic system. So the idea of the quality project is that the digital platform will help to have a really holistic zero defect solutions, and also a very automated system, so that the quality is automatically not only followed but also corrected, so that the manufacturing steps can be, the manufacturing machinery and manufacturing steps could automatically correct if something seems to go wrong. So for that, there is a platform called Zero Quality Platform created, which relies on the very much on the existing infrastructure that is there already. So it is connecting to the manufacturing equipment, the industrial PLCs, and using as much as possible these existing structures and data collecting systems, also the services in between, that are analyzing, for example, the data, and then up to the ERPs and the decision-making, business decision-making systems. So as much as possible, it's using the existing infrastructure and trying to connect the digital tools and systems in there. And there are some examples from then and how to use it. For example, for the automated machinery that is actually has previously been working or has deviations in certain steps of the when working, is now getting data from the machine health and also from the characterization and from the different process steps, milling and so on. And it is now automatically noticing already before that some deviations may happen and corrects itself. So it's a very practical way that, but it cannot be done without collecting the right data from different places and also analyzing it and having the service sort of to do things better. So the sustainability aspect or green manufacturing aspect, of course, here is quite evident. So it is not to produce scrap and also to have high quality products that are then at the customer's place working fine. So that is the green manufacturing result. The second example is from the DigiPrime project, which is then starting really from the circularity aspect. So that in the circularity, you need to share the data between different sectors. And here, of course, the challenge is that some things are quite easy to circulate, like simple materials, plastic bottles or whatever. But in some cases, especially in high-quality complex products, you should need a lot. You need to know what it includes and how it has been used. So lots of complexity is added to that. So here, for example, one of the examples is the batteries. So the electric vehicle batteries, we know it's a huge problem that these are degrading and what to do with them afterwards. We're having all these specific materials, not very environmental friendly either. So what to do with these batteries that are not good for the cars anymore? And it's 10 years or something, so it's you have to do something. So this is this DigiPrime network or platform is collecting these kind of examples with high value products and finding new lives for them. For the battery case here, for example, you sort of start from the input sector, automotive, and go for example, with the yellow line, so you can use them, the batteries, I mean, refurbished, of course, or remanufactured in the renewable energy, but in the stationary energy stations instead of mobility, where they are not good enough any longer. But you need to know how these are used. Or similar, if it's not good enough, so you might need to then come to the end-of-life solutions and try to utilize the materials instead. And it has similar examples of different products for mechatronics, electronics, some materials, and some others. Yeah. But this, and one more aspect here is that they also want to show them, like for in the battery case, it is that the platform is needed to make this possible, but also in cases that are more mature, like the electronics, for example, there's already existing circularity solutions, but those might not be very efficient. So the DigiPrime platform shows that you can make it more efficient, more also economically possible to do it. So at this is of course also a very big obstacle if you can circulate, but it's not economically viable. The Connected Factory CSA that I mentioned is not coordinating, but helping these projects in the digital manufacturing platform. So if you are interested, you can find a lot of cases in the EFRA portal, because we're working in this Connected Factories together with EFRA very much. So there's plenty of good examples of these digital platforms and connected to the green manufacturing, but also other cases. So the innovative cases you can find there. The CSA project, the Connected Factory, is also doing some other work than supporting the innovation actions. One particular connected to today's topic is that we have been creating different kind of pathways. So how to help the companies to, in this complicated transition towards more digital and more circular, how to grab this opportunity and how to sort of try to design the next steps and the ambition level, so to say. This is a very rich slide. Please don't try to read it. And the left-hand side is just saying that is describing how the manufacturing companies could advance towards data valorization, so to say. So there can be different steps starting from very, so to say, elementary to advanced, or how to collect data, how to use it, what aspects become important, so that you can, if you wish, go to the data valorization. And as a sister pathway, there's the circularity pathway, which also sees that how the manufacturing companies come from the very linear business where your sustainability means that you follow the regulations, towards the very advanced where the circularity itself is built into the company processes and also a business opportunity. Okay, then I will give a couple of examples from Finland. So this is when we're talking about this going towards the circular and green manufacturing, we of course need to evaluate if we have done it right or not. So Finland VTT together with the University of Lappeenranta has sort of defined a handprint, an environmental handprint concept that is actually not only measuring how to diminish your own footprint, but really looking at what is the handprint of the new products and businesses that you have. So the positive effect, like we could simply say, for example, the electric car compared to the conventional one. This example is from Ecox Finland. It's remanufacturing laptops, and there was a comparison between of using a new laptop for some 4 years or so, or remanufactured laptop, and you can then see that you can of course save in the materials and energy and so on. But the handprint is in a way very good because it is the positive communication that companies very wish to use. Of course, you need to also have it. We have used this handprint type of concept also in other cases. The Finnish technology industries have launched already some years ago, actually, a very big effort to look at the different sectors within their businesses to see what is actually the potential, the potential to diminish the CO2 emissions, but also the handprint of the Finnish technology industry's products, which we quite often export, and the sort of the potential is actually 5 times bigger in the environmental products, and when we look at their life cycle, when compared to the sort of the bad footprint that the companies have. And this actually, the handprint can become even more larger bigger if we can see that the business really changes towards the sustainable, so that the markets are developing into a positive, so that handprint can even grow. So this is just a quite direct estimate without looking at the growing markets in this field. So if then the last to see that these companies that I discussed in the technology industries, of course, include big and small companies, but often we think that the small companies don't do it or cannot do it. We had a quite interesting query among our network of SMEs, so maybe they are not the laggards because they at least talk to VTT. But anyway, so it was a quite nice result, actually. We were asking, how do they see their businesses in 2030? And it's a bit much text there, but I mean, there's a lot of things that have been discussed in this presentation are actually in the wish list of the SMEs. So if we look at here, for example, half of the ones that answered, about 200 companies, they see that circularity is an essential part of their businesses in 2030. And also they see that the sustainability offers a lot of business opportunities, 70%. So this is really a good result. And of course they have reduced their CO2 footprint. And also we can see that the digital part is there. They want to use artificial intelligence, or half of them, but they really see that they need a cross-company boundaries enables broad digitalization. And the small companies, when we are talking about them with them, so they really see that they want to do it with the other ones at least, because they have to. So it's, but still I think this is a very positive picture that not only the big companies, but even the smaller ones would like to make this change. So from VTT side, VTT is active, of course, in the European collaboration. Just wanted to mention that in this digital platform play, we have also been quite active. So we were, and Finland was one of the, in the first sort of wave of the international data space hubs. So we were there, VTT was hosting it, or is hosting it already all the time. And also we are quite active in the GaiaX collaboration together with the Sitra from Finland. And in particular, my colleague Päivi Kivikyttö-Reponen, she is coordinating the Finnish circular economy subgroups in the GaiaX collaboration. So we are very happy to continue and help to do this journey with combining the digital platforms and the circular transition. So to summarize, well, clearly, I mean, the digital the digital platforms are a must, an enabler for this green transition and green manufacturing. And there are a lot of good examples already. Not all of them are yet in a full business, so to say, but that they will be, or similar will be. And what is very positive that the companies really start to think, or if not yet previously, or if not previously, at least now they start to think this is a really big business opportunity to be in the front line in this green transition. And for the manufacturing companies, it's not only about the small footprint but also very much about the big handprint for the other companies as well, of course. And of course, I mean, this is not yet done, and it's a complex challenge we are facing. So the collaboration here is must, and not only nationally, but also European and international. Thank you very much.
Now it's about time for a round table. I mean, for the audience, maybe to interact with the yes, sir. So we'd like maybe to sit in the front, the speakers, the four speakers.
May I ask a question?
Let's first.
I have a question. My name is Andreas Gleichen from Siemens Energy in Sweden.
Yeah.
Do you work with shadow pricing? If a manufacturer emits a certain amount of CO2 emissions, how that can be calculated into a business case?
Well, I'm not totally sure if I'm the right person to answer to that. Sorry for that.
Okay.
We can ask somebody else maybe afterwards.
But do you in Siemens work with this?
Yeah.
Yes,
Yeah.
we started a month ago.
And this is kind of country regulation, or is that Siemens regulation?
Siemens Energy. I'm not talking about Siemens AG, I'm talking about Siemens Energy. We are carved out, so we are a different company now.
And Siemens Energy is introducing this rule.
Yes.
Okay, that's very interesting to know. But a company like Siemens.
Siemens Energy.
All right. Next question before we go to Bjorn. Any question from the audience? Yes, sir.
Yes, my name is Daniel. I'm with BASF.
From BASF. From what company?
BASF.
BASF.
So you mentioned that digital manufacturing solutions can be an enabler for green intrinsic motivation before, yeah, for each company to reduce, for example, energy requirements, input material consumptions, and so forth. So my question is, to your mind, what is different now, and how much is the remaining lever, yeah, and what is driving, let's say, how much more can we get efficient, how much more can be optimized, yeah, and what is different with this, with some of these three movements?
So maybe one of the things that is not yet there, I would say, at least not in every branch, is that the circularity aspect. So I mean, if you start manufacturing from used materials, or if you want to refurbish or remanufacture complicated products, complicated high-value products, so there is still a lot of things to be done. So it is not simple, and it of course might be that not even the original equipment manufacturers are doing. It might be somebody else, but it is manufacturing kind of thing. But you're doing things in a different way. So I think that is the main challenge, and in particular in the complicated and sort of products where the use life is long. So that would, I think, it's the challenge.
Let me give you maybe a monolithic answer. What's different? Data. That's what is different now than maybe 5 years ago or 10 years ago. So what is now different is that the data are much more available because of Industry 4.0 developments and sensing developments and machinery developments and so on and so forth. Data are much more available now than it used to be. Now there is an issue what to do with this data, because now we collect a lot of data and we do not know sometimes how to use it. But the challenge here is that this data can be also used for circularity purposes, for green purposes, and so on and so forth, that we did not used to have it before. So that's one aspect. The other aspect that I would like to bring to your attention, since you asked that question, is that it looks like that the manufacturing industry does not have such a huge footprint in terms of environmental impact. What is much more important for the Green Deal and for the greener aspects of manufacturing is the ability to manufacture new green products. The products are the ones that do have the major impact on the environment. And the question is, I think some of these talks touched upon, is who's going to make these new products that are environmental friendly, that are more, that consume less energy, consume less raw materials, and so on and so forth. The manufacturing industry. So the challenge for the manufacturing industry is to find ways of doing it in a way that will produce these new products efficiently, cost efficiently, energy efficiently, and raw materials efficiently. That's, if you translate what you heard about this afternoon, this is a key issue. Product, manufacturing of the products will be an issue. Because the products are the ones who are having the major impact on the environment. Yes, sir.
I can add to that. We made a master thesis study only last month, and we worked with additive manufacturing of gas turbine components, and to our great disappointment, the energy consumption of the additive manufacturing was higher. But as our gas turbines become much more efficient, it's a no-brainer. It is so logical to go for additively manufactured components because they produce 20 years or less pollution.
That's the basic idea.
Yeah.
That
You-
sometimes
You see the handprint there.
right. That's what that's the key issue. That maybe the manufacturing process may have a little bit higher environmental impact, but will produce a product that at the end will have much less environmental impact. That's what we are taking. Very good point.
Okay,
Any
I think data okay, this is very relevant, but I think there is an increasing request, I mean, for all this. I mean, okay, social requests from society comes from years ago, but it's growing. Then there is, for instance, manufacturing SMEs. They didn't feel any pressure until the OEMs are asking them, okay, which is your footprint, how you are doing it. Then there is, even at many sectors, there is new regulation. It's new as well, and this is coming. Finally, also it's an issue of financial aspects. I mean, we see this new taxonomy to provide finance that will take into account which is the environmental impact, and this is also giving some extra stress, let's say, no, extra or request, as we can understand. So I think it's coming from different sources, and now it's the time for it.
Yes, I had some question to Rika, but maybe first one thought to this very relevant discussion or the question, what is different? Yes, I think the data are now there, but I think also the human factor matters. So the mindset is changing from the decision makers. Just to give you one example, our company offered two components, one conventional classic component to our customers and one energy efficient component, which was a little bit higher in price, but helped in the end during the whole life cycle to save energy and also to save money in the end. But for a long time, the customers have not been interested in this eco-efficient component because they just had the purchase price in mind. So now the mindset is a little bit changing, different, and as I've also mentioned, I think the sustainability key performance indicators we have talked about before the session maybe become more and more important. Also financial figures, also this regulation discussion has an effect. And maybe this is my question, things like the green handprint help. So I'm not familiar with this handprint. Maybe you can explain a little bit what is the difference. So I understand that the footprint is the CO2 emission we have produced, but the handprint is the CO2 we have saved because of new alternative options.
Yes, so the handprint idea is exactly that. So I mean, we often talk about this footprint, so what is the harm done, so to say, and how it diminishes, which of course is very important to do. But when we are really going to the life cycle thinking in a way that what is this product doing during its life cycle, and thinking about the alternatives, exactly what that was said, that they might cost in the footprint a bit, but I mean the handprint of the product done differently is big, and this concept is not worldwide yet, but it's been becoming more popular. It wasn't really developed by well, it's based on all the standard, let's say, calculations, so it's not like developed like this, but anyway, it was first introduced by VTT and the university, and it's been developed further to the environmental handprint, and my colleagues are, of course, experts to explain how to really calculate it, but it is something that has gained quite much attention recently, at least in Finland, hopefully a bit abroad as well. So it is a way to communicate the positive impacts, but also the important things, of course, is that it also should steer your doings, so that it's not only measuring, but you also, when you have these LCAs or handprints, that it makes an effect to the decisions to do things differently.
From the research point of view, I would like to highlight and maybe ask the audience if you know, I mean, it is quite hard to train and to educate researchers, both in the universities but also in the industry, to calculate and to understand what is about environmental friendly, what is the footprint, what is the handprint, etc. I mean, it is the level of training these people have is up to the efficiency of the products, cost maybe, speed, and that's it. And if you want to make this kind of analysis, you need to train these people and to have this philosophy. Yes, please. That is.
So we realized some 7 years ago that a full life cycle assessment is simply too expensive. Costed between 5 and 10,000 euros per component. And then now in this spring we conducted this simplification where students were supposed to make a little Excel table and get a quick assessment that anybody without previous knowledge can do. They have just finished. I don't know if that really works, but the intention is to force us to do SBTI, science-based target calculations on all components that we transform from traditional manufacturing to additive.
Yes. And maybe from the lab to the fab. That is knowledge that should be also there, because I mean researchers and R&D people, I mean, have no idea about all these concepts and calculations.
This tool is not for that purpose, but yes, could be.
Yes.
The simpler is the method, the better is applied. The quicker is applied. Yes, sir.
Hi, hello, and thanks for the very good presentation, first of all. I'm Doras Dimitriou from CERT-ITI, Greece. And my question is the following. If we forget about government incentives, legislation, and so on, does a circular economy model, business model, is it in fact competitive to a linear one? So if we leave aside incentives, artificial incentives from government, legislation, and so on, does a company that produces a circular product have a competitive edge over one that follows, a linear, classic, let's say, manufacturing approach, not circular?
Sure. That's $6 million in question.
It's a market question.
The reason I'm asking is that because in Europe we are sensitive about this matter, about the
China,
environment,
yeah.
about the Green Deal, about the transition to a circular economy. We care for this, okay? But European factories have to compete in a global level with countries that often do not have disregard, let's say, for environmental issues. So are we providing our industry with a competitive edge by, introducing circular business models, or there is a gap there that we need to...
There's always, let me give you a few comments on that, because I know that question for quite some time, and that has been for quite some time, that artificial import regulations make industry less competitive. Okay. Let me give you an example from the old times. When I went to Germany, they used to do a lot of work in manufacturing for how to reduce noise in factories. Why? Because they had a very strong union in Germany, and the union in Germany was pushing the factory owners, the business, to make production quieter, less decibel. And I recall how much technology was developed because of this requirement. And that technology became slowly so competitive that the Germans, as usual, they exported all over the world the technology that they developed, while at the beginning, when the technology was to be developed, a lot of people in Germany said, look, we are going to develop, the unions is making us less competitive, and so on and so forth. It's a matter of time frame. I know China is not caring about the environmental impact, at least not as much as the Europeans. But as long as technology is developed that makes the environmental impact less, and maybe also make also other kind of renewable energy and so on and so forth. But for the time being, of course, if the barrel of oil is $25, there's no renewable energy competitive. But if the barrel of oil is $200, then the renewables is competitive. So the question is, timing and how things are involved also politically. Because you cannot leave the politics out of this. That's,
And the consumers.
and the consumers,
Yeah, good point.
and the market. Because a lot of Europeans do not like to buy products that are not green nowadays. They did not used to have it 20 years, 30 years ago.
I believe
Yes, I would like to make 3 comments to this very, very good question. First, I think there is also a mechanism, a legislation, I do not remember the correct title, so a specific tax on products coming from out of Europe, which are not following the same environmental regulations. So that, for example, from China, the products are then also more expensive.
But China is against it.
Yeah. So this is this legislation, and then the second comment, it's exactly George what you have mentioned with this Festo automation experience solution I've presented. We are able to reduce energy consumption and at the same time increase the lifetime of some products and also help our customers to earn to save money. So it's not only energy efficiency, but in the end also better total cost of ownership. So it also makes them more competitive. And the third point is we in Europe, I think I've mentioned this human experience matters, so we should be aware that we cannot compete on with standard products. So we always should bring our customers a specific value added, a specific experience, and this is what I see with this more and more servitization, more service offerings, and I think this is a unique selling proposition from Europe.
Siemens Energy has now decided to go for 100 euro shadow price per ton CO2 emission. That's an internal way of calculating, but I understand it is supposed to be a preparation for a near future when taxes or customs are introduced. And that's why I ask if anybody has a good business model calculator for that, because we look for someone.
Okay, I think the discussion was very interesting, I must say. Thank you for your time and the effort. We are closing the session now. It's 4 o'clock. Thanks again, David.